Hi students, good evening. Happy New Year to you. Welcome to this video session. My name is Samuel Dominic Chukwu Emeka, aka Some Dumb for Peace. In this video session, we shall discuss the standard normal distribution. Please, it is highly recommended that you read the notes and view the videos uh, on normal distribution. Those are in my website. The links are in my website. It is recommended that you read the notes and view the videos on normal distribution before you view this study guide. Then after you finish the study guide, then you can now work on your assignment. As usual, these study guide videos, we are just going to use technology to do it because in the actual notes and videos, we did it manually. We show our work and do it manually. So the study guide videos, we are just going to use technology. And the technologies we are using, we are going to use the calculator on my website and the Pearson Statcrunch that comes with my stat lab. Okay. So let's begin. Question 1. What requirements are necessary for a normal probability distribution to be a standard normal probability distribution? So if you look at the notes, let's get on my website. We can go to the mobile friendly site. I'll click on my site, mathematics, statistics, notes. So you go to normal probability distribution. One of the properties of the standard normal distribution is that the mean is 0 and the standard deviation is 1. So we talked about it in the video on normal distribution. So that's one of the properties. This enables you to use the standard normal distribution table. The standard normal distribution table, or your normal distribution table, that's this right here. I got this from the University of Florida. But you have several institutions that have this table. And in the videos we did earlier, we talked about how you read these tables. So I'm not going to use these tables here in this video because I have already explained it in prior videos. So I'm just going to use my calculator and the Statcrunch, Pearson Statcrunch that comes with your course management system, MyMathLab. So that's all I'm going to do. So please read the notes and view the videos. Let's get on my calculator. You can go to resources and we shall use probability distribution calculator. So that's question 1. The mean is 0, standard deviation is 1. Question 2. I would like to position this. Let me minimize this. Let's get this. Actually, I can close this. Okay. Let me close this also. I just have this calculator. Yeah, I would like for you to see it side by side. Also, in this video session, we shall discuss the uniform distribution. So, because I see the next question is uniform distribution. We'll discuss it and also the standard normal probability distribution. So, the question 2, the waiting times between a subway departure schedule and the arrival of a passenger are uniformly distributed between 0 and 7 minutes. Find the probability that a randomly selected passenger has a waiting time greater than 4.25 minutes. Okay, so when you get on, so let's do this, okay? I solve it with my calculator. The next question I solve with Statcrunch. The next question I do with my calculator. And we just do it that way, okay? And if there's any question that Statcrunch cannot do, my calculator can do it. Yeah, trust me, I spent a lot of time writing the codes for these calculators. I thank God it works. Okay, so you just click on uniform distribution. You click on uniform distribution here, and this is what we need here. Let's kind of, I want to make this to, so we can see it, the two. So you just come to uniform distribution, and the minimum here is 0 minutes equals 0. Maximum is 7. And you come here, more than, what's the probability that the waiting time, that the randomly selected passenger has a waiting time greater than 4.25 minutes. So just press more than here and put 4.25 here. And you can press the enter key or you just click calculate. So the probability, with my calculator, I provide more details. That's the thing. So if you're doing it, I write these calculators so that if you're, like, if this was a traditional classroom, some professors will want you to find the length first, then the height, then before you do the probability. So if this was a traditional classroom, then you need to show all your work. So the probability here to 3 decimal places will be 0.393. Okay, 0.393. 0.393. Enter. Okay. The next question, question 3. The waiting times between a subway departure schedule and the arrival of a passenger are uniformly distributed between 0 and 6 minutes. Find the probability that a randomly selected passenger has a waiting time less than 0.75 minutes. So let's do this one. Let us do this one with Statcrunch. You go to question help, go to Statcrunch. And here you go to start, you go to calculators, you point your mouse on calculators, and you pick uniform, because this is uniform distribution. You see uniformly distributed. Okay, so this is for standard one, this is between. Here, lower limit is 0, upper limit is 6 from the question. And they're asking probability that the waiting time is less than 0.75. So you come here, you put 0.75. And you can either press the compute button or you tap the enter key on your keyboard. So this is 0.125. That's the answer. 0.125. Okay. Question 4. A statistics professor plans classes so carefully that the lengths of our classes are uniformly distributed between 48.0 and 58.0 minutes. Find the probability that a given class period runs between 50.25 and 51.5 minutes. So my calculator, that's my turn. My calculator, my turn. So I just click on this. Actually, let me move it this way. So this is asking for between. If you look at my calculator, this one is just when they give you less than or greater than. If you look at this, this is less than, more than. That's when you use this. But for the between, you have to use this. Okay, if they give you the x1 and x2, the values of the variable, two values of the variable. So here, from the question, the minimum is 48.0, which is 48. The maximum is 58. And between 50.25 and this is 50.25 and 51.5. Enter. So the answer, the probability is 0.125. We put it here, 0.125. Okay. Question 4, Statcrunch. Now, for Statcrunch, for question 5, Statcrunch. Now, but for Statcrunch for question 4 that we just did with my calculator, you can use this also to do it. Okay, just put in these values. Okay. Question 5, we now do it with Statcrunch. We do one question with my calculator. We do the next one with Statcrunch. We do the one after that with my calculator. The one after that with Statcrunch. So we just do it that way. That's fine. This is no longer normal distribution. This is a normal distribution. Find the area of the shaded region. So I'm going to come here. I go to start. This is no longer uniform distribution. This is now normal distribution. So you go to start, you go to calculators, you go to normal. And this is, they gave you the z-score, which is 0.24, and they want you to find the area to the left. So area is the same thing as the probability. It's the same thing as the percentage. Okay. So with a standard normal table, as you can see, the mean is 0, standard deviation is 1. So all you need to do, I know they wrote x here. Don't worry about that. I know you saw z, but that's fine. Just put 0.24. I know they wrote x, and you see z here, no problem. It's the same thing, because with the standard normal distribution table, it is with mean 0, standard deviation 1, then is z. That's actually in the next section, which is 6.3, if it is not a standard normal distribution table, that means if the mean is not 0 and the standard deviation is not 1, then we have to use z-scores first. We have to convert the variable to z-score first. Then we can now use the standard normal distribution table. The conversion to z-score, or z-score is a standard score, that conversion is necessary for us to now use the standard normal table or standard normal distribution table. Right now as it is, that's fine. So this x is your z actually, because this is 0 and this is 1. This is a standard normal distribution table. So this is your Z actually. Okay, but when this is not 0 and this is not 1, then it is X. And then we have to now convert this X to Z before we can now use the table. And that is in section 6.3. But in this section, that's fine. This is actually Z, okay? So you just put in this and press compute or tap the enter key. Okay. So to 4 decimal places, the probability or the area of the shaded region is 0.5948. Okay. My calculator is next. With my calculator, just go to normal distribution. And this is, they gave us the z-score, but area to the right. Area to the right. So you just come here, under normal probability distribution, the z, type -1.19, okay? Enter. So with my calculator, I gave you both the left and the right probabilities. Okay, area to the left and area to the right. So just use what they asked you. So in this case, they asked us area to the right. So we'll put to 4 decimal places, it will be 0.8830. 8830. Okay. Question 7, Statcrunch. Now this is between. This is between. So just, this is in standard, just press between right here. And this is the standard normal distribution table. Mean is 0, standard deviation is 1. So just put this, -0.86. The probability or the area between -0.86 and 1.22. 1.22. Enter. So to 4 decimal places, this is 0.6939. Okay. Question 8. My turn. My calculator. Question 8 is now asking us to find the z-score. They gave us the probability or the area, and this is to the left. And they now want us to find the z-score to 2 decimal places. Of course, when we discuss z-scores, we say that z-score is usually rounded to 2 decimal places. So in this question, you are going to use the inverse normal distribution. And with your TI, if you have a TI 84 plus, you can also look at my tutorial videos on how to solve these problems with the TI 84 plus. If you're doing this question now with my calculator, you will use the inverse normal distribution. And also, if you're doing it with the TI 84 plus, you have to use the inverse normal distribution function. So I'm going to scroll down here. This is normal probability distribution. You use this if you're asked to find the probability. But when you're given the they give you the z-score and they want you to find the probability, you use this. Or they give you the variable and they want you to find the probability, you use this here. But when you're given the probability and you're asked to find the z-score, then you have to use the inverse normal probability distribution function. So you scroll down up to here, inverse normal distribution. And in this case, this is area to the left. So we're going to use left. Okay, area to the left. So you put 0.9761, enter. So the z-score, you just round it. The z-score is 1.98. You round it to 2 decimal places. I didn't round it because, I want you to now round it yourself. So 1.98. Okay. Question 9, Statcrunch. So in this case, this is also area to the left. Area to the left. So we're gonna, but this is not, this is less than, not between. So press standard. In this case, they gave us the probability, and we need to find the z-score. So like I said, this x is actually your z, because this is a standard normal distribution table. So what you do is just come here and just type in the 0.2266. That is the probability. And this is to the left. If it's to the right, then you change it. But this is to the left, so you leave it like this. And just press compute. So the z-score here is negative 0.75. Negative 0.75. Okay. Okay, the next one is my calculator. They gave us probability to the right, and they want us to find the z-score. So you just use this here. Okay, you use this here. The probability is 0.9222. Enter. So the z-score here is negative 1.42. To 2 decimal places is negative 1.42. Okay. Next one, Statcrunch. They gave you probability to the right. So you come here, change this to probability 0.1271. Okay, that's the area to the right, or probability to the right. And this is to the right, not left. So you click here, you select greater than. Okay, greater than. And it shows you here, it shows you that this is the area to the right. So this is area to the right, or probability that is greater than. Probability that the z-score is greater than 1.14. Okay, that's this. It's equal to 0.1271. That is what it means. So probability greater than, or area to the right. That's the same thing. So this is, the z-score is 1.14. 1.14. Question 12. Assume that a randomly selected subject is given a bone density test. Those test scores are normally distributed with a mean of 0 and a standard deviation of 1. So that shows you you can use the standard normal table. Find the probability that a given score is less than negative 1.36 and draw a sketch of the region. So less than negative 1.36 is just this here, less than, area less than, okay? And this negative 1.36. Because this option A is the area between negative 1.36 and 1.36. Option B is the area less than negative 1.36. Option C is the area less than 1.36. Option D is the area greater than negative 1.36. Okay, so area to the, actually I should say area to the left, or the probability that it is greater than. So let me say it statistically in a statistically correct way. Okay. Option A is the area between negative 1.36 and 1.36. Okay. Or you can say the probability that negative 1.36 is less than or equal to z is less than or equal to 1.36. Option B is the probability that the z-score is less than negative 1.36. Or you can say area to the left of negative 1.36, that's less than. Okay. The probability that the z-score is less than negative 1.36. Or you can say area to the left of negative 1.36. Option C is the probability that the z-score is less than 1.36. Or you can say area to the left of 1.36. Option D is the probability that the z-score is greater than negative 1.36. Or you can say area to the right of z equal to negative 1.36. Okay, so actually this is B. Okay, and then what's the probability? We can just do it here. Left, we need the z-score is negative 1.36, and we need less than. Okay, so the probability is 0.0869. Question 13, my turn. Find the probability that a given score is less than 1.97. So less than 1.97 is this here. Okay. So option B. And then the probability, I'm just gonna go, they're asking us for probability. So I'm going to use the normal probability distribution. And then Z, in this case, is negative 1.97. Enter. And the less than will be this here. Okay, 0.0244. 0.0244. Okay, I'm sorry. I put negative 1.97. That should be 1.97. Don't mind me. 1.97. Calculate. Okay, so that is 0.9756. 0.9756. Okay. So you see, I'm a human being. I make mistakes. It's only God that does not make mistakes. Only God. I thought it was negative 1.97 without realizing that it's 1.97, you see. But the nice thing about these assignments is at least you have the chance to keep on doing it until you get it right. Okay? Only God does not make mistakes. Every human being will make mistakes. So the probability is 0.9756. 9756. Okay? Question 14, Statcrunch. Assume the readings on thermometers are normally distributed with a mean of 0 degrees Celsius and a standard deviation of 1.00 degrees Celsius. So in this case, you can use a standard normal table. Find the probability that a randomly selected thermometer reads greater than. Find the probability that a randomly selected thermometer reads greater than 1.41 and draw a sketch of the region. So greater than 1.41 is actually this here. 1.41. Now, remember that, your normal distribution curve, the total area is 100% or 1. So area can never be negative. Okay, area or probability can never be negative. The total area is 100%. The total probability is 1. It can never be negative, no. But the z-scores can be negative or positive. So when you at the center, the z score at the center is 50%. Okay, 50% to the left, 50% to the right. Okay, and at the center you have the mean. The mean is 0 at the center. Okay, the mean is 0, and the standard deviation is 1, and that is why it is a standard normal distribution table. Okay, so to the right of the mean, the z-scores are positive. To the left of the mean, the z-scores are negative. Okay, does that make sense? So just take note of that. The center, the mean is 0, the z-score is 0, but to the right, the z-scores are positive. To the left of that center, the z-scores are negative. But the areas or the probabilities are always positive, always. Okay, so take note of that. Greater than 1.41 is this. Of course, 1.41 is, you see, is to the right of like this is the center, the peak is the center. So to the right of it, this is a positive z-score. Okay. The probability, we come here, greater than, so we're going to change this to greater than. But let's put the z-score 1.41 and you select greater than. So the probability here is 0.0793. Okay. Question 15, my turn. Greater than negative 1.46. Greater than negative 1.46. So that is to the right. Area to the right of negative 1.46. So that is this right here. And then the probability, I will put here negative 1.46. Calculate. To the right, that gives us 0.9279. 0.9279. 0.9279. Okay. Question 16, the same thing, but here between 1.50 and 2.25. So let's use Statcrunch. The graph 1.50 and 2.25. The best option is this, because this here is greater than area probability that the z is greater than 2.25. That's area to the right of 2.25. B is area to the left of 1.50. C is the area between 1.50 and 2.25. So it's C. Here for Statcrunch, you click on between. Click between. And here just put 1.50 or 1.5 and 2.25. 1.5 is the same thing as 1.50. The probability is 0.0546. 0.0546. Okay. Question 17, my turn. Between negative 2.04 and negative 0.08. Now this one is to the left, area to the left of negative 0.08, so no. This one is area to the left of negative 2.04, so no. and the between one is actually this. Okay, so you check this. The probability, with my calculator for the between, use this here, use this too. The first z-score is negative 2.04. You press the tab key to take you to the next field. The second z-score is negative 0.08. Okay, enter. So I put it, excuse me, I put detailed probabilities here. Okay, I put probability that the first one is less than that, less than the second one. You know, I put detailed one here, and I put greater than, greater than. But the one you should be looking for is this. This is the answer you should be looking for. Now, for this one, there are some textbooks, they ask you away from. Away from. So away from means less than the first one and greater than the second one. That is some textbooks anyway. But I put detailed ones. But this is the question, this is the answer they need here, between. Okay. If you are taking this in traditional classes, some professors are particular about the way you write these. Some professors are particular. Nigerian, well, I don't want to, I don't want to mention some names, but I think Nigerian professors are more picky than American professors. I think Nigerian professors are kind of more picky. Okay, so the probability is 0.4474. Okay. Question 18, Statcrunch. Between, so this is negative 1.44 and 1.57. So you see, with this one, actually, you can even say it right away because it shows the graph. It shows the graph already. This is a 0.8669. Okay, question 19, my turn. Between negative 2.15 and 3.76. So negative 2.15, 3.76. That is this, option B. Negative 2.15 and then 3.76. And this is what you should be looking at here. 0.9841. 0.9841. Okay. Question 20. Statcrunch. Assume that a randomly selected subject is given a bone density test. Okay. Find the probability that the score is less than 3.78. Of course, that's this. You want to put it here. Just do less than. You put here 3.78. Enter. Okay, that's this. And the probability is 0.9999. Question 21. Assume that the readings on the thermometers are normally distributed with a mean of 0 degree and standard deviation of 1.00 degrees Celsius. Okay. This should be mean of 0 degrees Celsius. So that's the typo. Well, that's an omission. A thermometer is randomly selected and tested. Draw a sketch and find the temperature reading corresponding to the 84th percentile. This is the temperature reading separating the bottom 84% from the top 16%. So yeah, when we did quantiles, we discussed percentiles. So 84 percentile is actually the score, that reading, the reading that separates the lower 84% from the upper 16%. So it's gonna be lower 84%, and like I said, half is 50%. So if you look at this is less than 50% here to the left. Here, this is less than 50% to the right. No. Remember, it's gonna be, and we have to shade it. Like it has to be the shaded part, lower 84% from the upper 16%. So this is actually like we have to shade from the left. Okay, in this case, the 84th percentile. So this is not it, and this is not it either. This is the up. This looks like upper 84% now. So, but this is because this is more than 50%. Remember, half of it is 50%. So this looks more like it. Okay, if you expand it, looks more like it. So I'm gonna take option D. Okay, and then what is the temperature actually that does that? So they're asking us for the z-score, okay, because they gave us the probability and they're now asking us for the z-score. So you come here, you put 0.84, 84% is 0.84, and it is the lower part, so that's fine. You leave it as less than, compute. So the z-score is 0.99, okay, 0.99. Question 22, my calculator, 16 percentile. Okay. So in this case, I'm gonna use the inverse normal distribution to find the z-score. But the 16 percentile is the lower 16%. And this is lower 16%. This is more than 50% and it's to the right. It should be 16% to the left. That is why it is called lower 16%. This is 16% to the right. Okay. And this is actually 84% to the right. That's what this is. This is 16% to the left, which is the correct thing. This is 84% to the right. This is 16% to the right. This is 84% to the left. So the correct answer is this. Lower 16% from the upper 84%. And the z-score, the bone density score, would be what? So this is left 16%, and that is left 0.16. Enter. So the z-score is negative 0.99. And of course, remember, we said that the z-scores to the left, the left of the center, they are all negative values. So this is negative 0.99. Okay. Question 23, Statcrunch. Assume that the readings on the thermometers are normally distributed with a mean of 0 degrees Celsius and standard deviation of 1.00 degrees Celsius. Assume 2.8% of the thermometers are rejected because they have readings that are too high, and another 2.8% are rejected because they have readings that are too low. So draw a sketch and find the two readings that are cutoff values, separating the rejected thermometers from the others. So if you look at this, this one is just rejecting 2.8% that are too high. Okay, that's option A. Look at it. This is rejecting 2.8% that are too high. This is not what we want. This is rejecting 2.8% that are too low. But this is not what we want. We want to reject both. It has to be both. This here is the area between the 2.8% that are too low and 2.8% that are too right, that are too high. So this is the area between 2.8% that are too low and 2.8% that are too high. That is not what we want. What they asked us to do is to shade those areas of rejection. Okay, so this is not the rejection region, no. They want us to shade the areas that are in the rejection region. So this is this here. Okay, 2.8% that are too low, 2.8% that are too high. All right, so that is it. Option D. What are the cutoff values? Okay, so here we are gonna do, and that's the thing. If we see this kind of question again with my calculator, then I think you will appreciate it. But will appreciate my calculator. But with Statcrunch, we have to do it. We just have to do it step by step, and we'll put a comma to separate the answers. So let's go here. Standard, we put 2.8% is 0.028. Okay, enter. So the first one is the z-score is negative 1.91, comma, and of course the other one will be 9.91. Okay, because this the normal distribution curve is symmetrical. So if you're rejecting, this is if you put 0.028 here, okay, the other one will be 1.91, because when we discuss the normal distribution curve, one of the properties is that it is symmetrical. So if you're gonna reject the same percentages from the left and from the right, then of course one will be the negative z-score and the other value will be the corresponding positive z-score. Okay. Okay, these are critical values. I think we'll do this in chapter 7, critical values. But let's go ahead and do this. Question 24 is my turn. They want us to find the z-score. This means to the right, okay, area to the right, whereby the area to the right is 0.02. That is what it means. That is actually what it means. We'll talk more on critical values when we do estimating population parameters. So, but this just means find the z-score corresponding to area to the right. Area to the right is 0.02. So we will use the inverse normal distribution. Area to the right, we're going to use area to the right, 0.02, then enter. So the z-score will be 2.05. 2.05. Okay. Question 25, Statcrunch. Find the indicated area under the curve of the standard normal distribution, then convert it to a percentage and fill in the blank. About -% of the area is between z equal to negative 1.9 and z equal to 1.9. So 1.9 standard deviations of the mean. So that's fine. Just come to between here, go to between, okay, and put negative 1.9, negative 1.9, and then 1.9. So you convert to 2 decimal places after you have converted it to percentages. So this will be 94.26%. Okay, 94.26%. 94.26%. Question 26. Which of the following is not a descriptor of a normal distribution of a random variable? The graph of the distribution is bell-shaped, correct? The graph is centered around 0. Not necessarily. The graph is centered around the mean, correct? Okay. The graph of the distribution is symmetric, correct? So we are not going to say that the graph is centered around 0, no. If it is a standard normal distribution table, then the mean is 0, okay? The graph is centered around the mean, but the mean must not be 0. And that is why we have z-scores. So if the mean is not 0, then we have to convert to z-scores. So we can now use the standard normal table. In the standard normal table, the mean is 0, okay? But the mean must not be 0. And they didn't say here standard normal table. They just say normal distribution of a random variable. The graph is centered around 0 is only if it is a standard normal table, and that means the mean is 0. But the mean must not be 0, no. Okay, so the correct option here would be B. Okay. Question 27. Which of the following groups of terms can be used interchangeably when working with normal distributions? Areas, probability, percentages can be used interchangeably. Okay, option A, areas z-scores, no, they are two different things. Z-scores, probability, no. Areas z-scores, no, two different things. The last option, areas, probability, and relative frequencies, correct. So area, total area is 100% or 1. Total probability is 100% or 1. Total relative frequency is 100% or 1. Yes, so that's it. Question 28. A continuous random variable has a dash distribution if its values are spread evenly over the range of possibilities. So that is a uniform, okay? With the uniform, you say it's rectangular. The values are spread evenly. So it's uniform. Question 29. Which of the following is not a requirement for a density curve? Okay. A, the curve cannot fall below the horizontal axis. B, every point on the curve must have a vertical height that is 0 or greater. Okay, that's right. C, the total area under the curve must equal 1, correct? D, the graph is centered around 0. So the curve cannot fall below the horizontal axis is A. Wow. So so the option that is not a requirement for a density curve is the graph is centered around 0. Okay, it's not a requirement. It must not be centered around 0. Question 30. Which of the following does not describe the standard normal distribution? A. The graph is uniform. B. The total area under the curve must equal 1. Uh, yeah, so does not describe the standard normal distribution. Of course, it's not uniform. Total area under the curve is 1. C. It is the normal distribution with a mean of 0 and a standard deviation of 1. That's right. D. The graph is symmetric. That's right. So A. The graph is uniform. No, that is not a standard normal distribution. The graph is bell-shaped, as you can see. With a standard normal distribution, the graph is bell-shaped, okay, or bell-curved. It is not uniform. Question 31. Finding probabilities associated with distributions that are standard normal distributions is equivalent to finding the area of the shaded region representing that probability. Of course, that is the correct option. Question 32, the notation probability that Z score is less than A. Okay, A is a value. That's what it means. Probability that the Z score is less than A. The last but not the least, which of the following would be information in a question asking you to find the area of a region under the standard normal curve as a solution? So the first one is the critical value. They're asking you to find the Z score and they give you the probability to the right. That's the first one. B, a probability is given. C, a percentage is given. D, a distance on the horizontal axis is given. So remember this question, they're asking you to find the area or the probability. So that means they should give you the Z-score or the variable for you to be able to find the area. Okay, the area is the Z-score. The area is the probability or the percentages. So if they're asking you to find the area or asking you to find the probability, okay, that means they must have to give you the Z-score or they should give you the variable, the value of the variable. So it's not finding Z. It's not finding the critical Z. Okay, it's not. A probability is given. No, they're asking you to find the area. So why would they have to give you the probability? Percentage and probability is the same thing. B and C are the same thing, no? So the correct option would be that they gave you the Z-score or the value of the variable, okay? All right. If you have any questions, please feel free to ask. I hope you understood this. Thank you so much for listening. Please watch out for other videos. And you have a good night.